Section 7.2, Law of Sines. So we're solving triangles, and we've solved right triangles so far. But now we're going to solve not right triangles. A not right triangle is called an oblique triangle. In general, if we're solving triangles that are not right triangles, we're either going to use the law of sines or the law of cosines. And so this section covers the law of sines. When do we know to use the law of sines? Well, we're going to know to use the law of sines when one side and two angles, that is, angle-side-angle triangle or an angle-angle-side triangle, occur, or if we get two sides and the angle opposite one of them, which is going to be a side-side angle triangle. Now, we'll look at these specifically. The nomenclature ASA, AAS, SSA is just telling you the layout of the labeled known information in the triangle. Now, something to note is that if we have a side-side angle triangle, that is two sides and the angle opposite one of them, the trick is that in that triangle, three things can happen. Specifically, we could get one full solution set for the triangle. That is, there exists a triangle with one possible solution set. It's also possible to get two solutions. Now, the reason that this occurs is because, and we'll see this in practice, when we consider the sine inverse function, the sine inverse function is only going to find angles between 0 and 90 degrees that work for us, or they're going to find angles between 0 and negative 90 degrees. Since that's the case, you'll actually have to move those that end up in quadrant 4 into quadrant 2 because we can only have positive angles in our triangle. We'll see this in practice. Lastly, it's possible that you start solving the triangle and you discover at some point that it's technically an impossible triangle. And so we're going to confirm this using the angle measurements to see if that's the case. And we'll see one of these as well. Now, what is the law of sines? Well, the law of sines says that if you have this image we're looking at, a triangle, ABC triangle, then all you have to do is set up these equivalences. That is, the side opposite the angle A over sine of A is equal to B divided by sine of B is equal to C divided by sine of C. It's also equivalent if you want to put the sines on top of the side lengths, that's also okay, but this is our formula that is the law of sines. So let's actually try this. So we want to solve the triangle. A is equal to 20 degrees, B is equal to 82 degrees, A is equal to 4. So specifically, let's just label this. We know that A is 20 degrees, we know that B is 80 degrees, and we know that side A is 4. And notice that if you start at one location, we have an angle, 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 and a side. And so what kind of triangle is this? This is an angle, angle, side triangle. And so let's get to solving it. Well, let's do the easiest thing first. That is, we know that C is going to be 180 degrees minus the other two angle measurements, that is, minus 80 degrees and minus 20 degrees. And so 180 minus 80 minus 20 gives us 80 degrees. And so we're off to a good start. We know that angle C is actually going to be 80 degrees. Now, a couple things to notice if we wanted to make our life easier. At this point, we actually have an isosceles triangle, so this picture that we have here, my general picture, isn't correctly to scale, but that's okay, and if you know the geometry of an isosceles triangle, you can make your life a little easier. But if not, don't worry, we can find out everything we need to find out. And so, let's use the law of sines. Well, the law of sines says that if I take the side length that I know, A, and so A over sine of A, and once again be careful because the capital letters are my angle measurements, that's going to be equal to, we'll just pick one of the other side lengths we want to find. That's going to be B divided by sine of B. Okay, so let's fill in the blanks here. A is known to be 4. Angle A is known to be 20 degrees. Side length B is unknown, but B angle is 80 degrees. At this point, we just need to solve this ratio for B. And so I'm actually going to multiply both sides by sine of 80 degrees, multiply by sine of 80 degrees. This is then going to be 4 times sine of 80 degrees divided by sine of 20 degrees. that's going to be equal to side length B. Make sure you're in degree mode when you use your calculator. And at this point we do need to round somehow, so I'm just going to arbitrarily round to 2 decimal places. Be careful, MyLabs will tell you how far to round. And so if I'm going to round to 2 decimal places, or the hundredths place, that's going to be 11.52. And so now I know that side B is 11.52. If you recall what an isosceles triangle is, that is, 2 side lengths are equal, then you now know what C is. But just to verify that, let's use the law of sines to set this up. Specifically, I can use 4 divided by sine of 20 degrees is equal to C divided by sine of 80 degrees. But recognize that this is the exact same equation that we had before, where C is in place of B. And so when we solve this one, we're going to get that C is approximately 11.52. And so we have completely solved this triangle, and we're done. So now let's try this one. We're now told that B is 25 degrees, C is 85 degrees, and A is 6. So let's fill it in. Side length A is 6, angle B is 25 degrees, angle C is 85 degrees. Notice in the layout, if I start at one place and move to the other, I have an angle, a side, and angle. So this is an ASA, or angle-side-angle triangle. Well, let's do the easiest thing first. Recognize that I can get angle A just by knowing that all the angles in a triangle added together equal 180 degrees, or we can say that A is going to be equal to 180 degrees minus 25 degrees minus 85 degrees. Then we get that angle A is going to be 70 degrees, and so now I know that angle A is 70 degrees. At this point, recognize that I have angle A being 70 degrees and side A being 6, which means I need to set up my equation, 6 divided by sine of angle A, which is sine of 70 degrees. Alright, but then I need to solve for side length C and solve for side length B. So, side length C is going to be C divided by the sine of angle measurement C, which is 85 degrees. So sine of 85 degrees. Then we just solve for C. I can multiply both sides by sine of 85 degrees. Then I get that C is going to be equal to 6 times sine of 85 degrees divided by sine of 70 degrees. Making sure my calculator is in degree mode. Rounding to 2 decimal places, I get that side length C is approximately 6.36. And so now I get that C is 6.36. Once again, pay attention to the rounding requirements. Well then, let's find side length B. So side length B is going to be, well, I have 6 divided by sine of 70 degrees is equal to side length B divided by the sine of angle B, where angle B is 25 degrees. So to solve for B, I can multiply both sides by sine of 25. Sine of 25. Then I get that B is equal to 6 times sine of 25 degrees, all divided by sine of 70 degrees. If I round to 2 decimal places, I get that this is approximately 2.698. 698 will round to 70. Pushes the 9 up to 10, becomes 70. So B is 2.70 if we round to 2 decimal places. We found all this information to this triangle, and we're done. Alright, so now we're solving the triangle B is equal to 35 degrees. Side length B is equal to 5. Let's fill it in. Okay. Alright, so let's recognize first what type of triangle do we have. Well, I have angle side side, or you could also say side side angle. It doesn't really matter, but for the initial nomenclature, side side angle. Alright, so let's recognize before we even get started that 3 situations could happen. We're either going to have one complete set for a triangle solution set and we're good, or we're going to have no solution possible, or we have 2 complete triangle solution sets that are possible. So we do have to be a little bit careful here. Alright, let's get into this. So, first off, if I have B, the angle B, and I have the side B. I'm going to have those anyway. I know that that's where I'm going to start my information. Now, I'm going to change up what I'm writing just a little bit. Earlier, I was putting the trig function on bottom. I'm going to put the trig function on top this time, just to make the algebra a little easier. So, if I have sine of 35 degrees divided by side length B, which is 5. Law of sine says that's going to be equal to, and at this point, I'm given side length A, so I've got to find angle A before I can go any further. And so side length A is 3. And we don't know what angle A is, so that's going to be sine of capital A. Alright, great. Now hopefully you see now why I put the sine function on top, because now when I multiply by 3, this then becomes 3 sine of 35 degrees over 5 is equal to sine of A. Now at this point, recognize what we have to do. We have to take the sine inverse of both sides. If you would like to do that first, that's fine. I'm going to do it all at once. That way I'm minimizing the possibility of error. Just make sure that you're careful about the way you type it in your calculator. So, A is going to be equal to sine inverse of 3 sine of 35 degrees divided by 5. Okay, so make sure you've got some parentheses in there. We're going to round to 2 decimal places, or the hundredths place. And so I get that sine inverse of 3 sine of 35 degrees divided by 5 is approximately 20.13 degrees. Okay, now, at this point, this is the situation where we can figure out if we have one solution or no solution. We can probably go ahead and figure out if we have 2 solutions or not. But step 1 is, do we have a solution set or not? Well, notice that 20.13 plus 35 degrees plus the angle side given. That's less than 180, so that means I have at least one solution set. Perfect. So I know that we have at least one solution set. Alright, but now we get to play the game of, do we have a second solution set? Okay, so to check to see if we have a second solution set, recognize that 20.13 on our unit circle appears here, right? Remember that when we find the inverse sine, we're either going to be in quadrant 1 or quadrant 4. But because we found an angle measurement in quadrant 1, recognize that all students take calculus and all students take classes, and the deal is that we could also have a second solution set over here, where this reference angle of 20.13 occurs. Alright, so what does that mean? I need to calculate what is this angle. Well, this angle is going to be 180 degrees minus 20.13 degrees. And I get that that other possible angle is 159.87. Now, if that's my possibility, let's add that to 35 degrees and 20.13 and see what we get. Well, the truth is that at this point, 35 degrees plus 159.87 is going to be too large. We're not going to make a possible thing. So that means that right at this point, second solution set, not possible. And so we're not going to have a second solution set, we're only going to have one. Alright, so back to our initial triangle. We found A now. A is 20.13 degrees. Now that we know angle B and angle A, and we only have the one solution set, we can find angle C. Angle C is of course going to be equal to 180 degrees minus 20.13 degrees minus 35 degrees, which I then get that angle C has to be 124.87 degrees. And so we found angle C. Of course, it's an approximation. Angle C is 124.87 degrees. Of course, it is approximation. But now that we have angle C, we can find side C using law of sines again. That's going to be side length B, or 5, divided by sine of 35 degrees is equal to side length C divided by sine of angle C, where angle C is 124.87 degrees. Multiply both sides by sine of 124.87, get that C is equal to 5 times 5 times sine of 124.87 degrees divided by sine of 35 degrees. And I get that that is approximately 7.15. And so now we have sine length C being approximately 7.15. I found all of the triangles. This triangle only had one solution set, and thus we're done. Let's try it again. I have angle measurement A, which is 50 degrees. I have side length B, which is 8. I have side length A, which is 5. Recognize once again I have side, side, angle. Alright, I need to find the angle B. So that's going to be sine of 50 degrees divided by side length A, which is 5, is equal to sine of angle B that we don't know divided by side length B, which is 8. Let's solve for sine of B, so I can multiply both sides by 8. This is then 8 sine of 50 degrees divided by 5 is equal to sine of B. At this point we need to take sine inverse of both sides. And so if I take sine inverse of both sides, that means that B is going to be equal to sine inverse of 8 sine of 50 degrees divided by 5, which I'm going to break up into two parts at this point. I recognize that if I'm trying to find the sine inverse, I could plug this all into my calculator, and if you do, you're going to get a domain error, but let's understand why. 8 sine of 50 degrees divided by 5 is specifically going to give me 1.23 approximately, and so the truth is that when I see sine inverse of a number bigger than 1, at this point we automatically know there is no such triangle that exists. There's no solution because no triangle could exist. Okay? And we're done. No solution. Alright, let's try another. We have C is 15 degrees. We have C is 15 degrees. We have side length C is 6. We have side length A is 10. Alright, so recognize once again this is side, side, angle. And so side, side, angle, we can probably take a wild guess as to what our next situation is going to be. But let's try it out. Well, I need to find first angle A. So, if I'm looking for angle A, that's going to be sine of A divided by side length A, which is 10, is equal to sine of 15 degrees divided by side length C, which is 6. Then, of course, multiply both sides by 10. Multiply both sides by 10. This is then going to be that sine of A is equal to 10 sine of 15 degrees divided by 6. We could reduce the fraction if we wanted, but really we just need to take sine inverse of both sides. And so now I have sine inverse of sine of A is equal to sine inverse of 10 sine of 15 degrees divided by 6. And I get that this is approximately 25.55 degrees. Okay, but once again, this is the situation where we have to ask ourselves, are we done and we have one solution that we cycle through, or is it possible to have two solutions? And so I'm just going to go ahead and get myself on track before I finish up, so I don't forget this. And once again, if we're finding sine inverse being 25.55 degrees is here, we also need to consider the fact that we could have a reference angle here of 25.55 degrees, and if there's a reference angle of 25.55 degrees over there, then we know that the angle measurement here is going to be 180 degrees minus 25.55. Alright, well 180 degrees minus 25.55, that's going to give us 154.45 degrees. Okay, so let's pretend for one moment what would happen if side angle A were equal to 154.45 degrees. Well, then I would have 154.45 plus 15 degrees. Well, that's going to give me 169.45 degrees that's less than 180 degrees, which means we're going to actually have two solutions. Okay? And so if we're going to have two solutions, let's get back to it. Let's return to our first solution set, and then we'll wrap back around to our second solution set. But I want us to know that there are two solution sets here. And it all is because when we take the sine inverse, you've got to be concerned about the angle that occurs in quadrant 1, and using that as a reference angle in quadrant 2 to check and see if it's a possibility. And it is. So, but let's return to our first solution set. So our first solution set, we now have that A is 25.55. So I'm just going to write this here. Solution set, alright, we have that angle A is equal to 25.55 degrees. Okay, and if it helps you to sketch two triangles, you can. I'm going to write them in now, but that's why I've got this solution set 1 here. So if A is 25.55 degrees, now I can find angle B, where angle B is specifically going to be 180 degrees minus 25.55 degrees minus 15 degrees. So I get that B is 139.45 degrees. Okay, and just for my picture to keep myself on track, 139.45. Alright, so I'm going to underline the ones that I'm going to erase in a few minutes anyway, because I'm going to get my second solution set and I'm going to draw them in. But now I just need to find side length B, but to find side length B, I know that C is 6, angle C is 15, so 6 divided by sine of 15 degrees is equal to side length B divided by sine of 139.45 degrees. Multiply both sides by sine of 139.45 degrees. And so then I get that side length B is 6 times sine of 139.45 degrees divided by sine of 15 degrees, which I get to be approximately 15.07 when rounded to 2 decimal places. So my first solution set, or with the smaller a value, is this. I'm being a little loose about my approximation symbols here. I should be a little better, but recognize that at some point if we're doing applications, then finding the close enough measurements is probably what you need. Alright, so we found solution set 1. Okay, so let's return to solution set 2. Let's recall, first off, what did we do? We took that initial angle that we found its equivalent angle, where it's a reference angle of quadrant 2, which gave us 154.45 degrees. And so if we want, we can go ahead and start writing down solution set 2. Because now I know that for solution set 2, I have the angle measurement A is equal to 154.45 degrees. Alright, so I'm going to erase the things that I found earlier and throw in my second solution set into my triangle, because of course these were the givens. Alright, so once I find angle length A, then I can find angle length B. Well, how do we find that? Well, angle length B is of course going to be 180 degrees minus 154.45 degrees minus that given 15 degrees, which I get to be 10.55 degrees. Okay, so now we've got angle B is 10.55 degrees for a second completely separate triangle. So there we are. Angle A is 154.45 degrees, and angle B is 10.55 degrees. Okay, so then I just need to find side length B, but to find side length B, it's really exactly the same as we did earlier. That's going to be 6 divided by sine of 15 degrees is equal to side length B divided by sine of angle B, which is 10.55 degrees. Multiply both sides by sine of 10.55, and so I get that side length B is equal to 6 times sine of 10.55 degrees, all divided by sine of 15 degrees, which I get to be a side length of 4.24 when rounded to 2 decimal places. And so now I have my complete second solution set, which is here. And so there we are. Solution set 1, solution set 2, two completely different triangles that were given from this same side-side angle setup. So now we've seen all three possibilities for side-side angle. Alright, but now we have a little bit of critical thinking that we need to do. To find the length of the span of a proposed ski lift from A to B, a surveyor measures angle DAB. Alright, DAB, recognize that that's just this angle, and discovers it to be 25 degrees. And then they walk off a distance L of 1,800 feet. Okay, so we discovered that L is 1,800 feet to the point C, and they measure the angle ACB to be 15 degrees. Now they ask a specific question. They want to know, what is the distance from A to B? And we don't want to round until the final answer. Alright, so the distance from A to B, this is what we want. This is our goal. Okay. Now, what do we know? Well, I claim that what we have here is an angle, side, angle triangle. But how do I know this? I know this because if I'm looking at this picture and I recall the geometry, this angle right here is really on a flat. And so notice this flat. A flat is 180 degrees, so I know that that angle measurement A is actually equal to 180 minus 25 degrees, and so I know that angle A is specifically 155 degrees. Okay, great. Well, then I have a angle, side, angle triangle, right? And we can find the solutions for this. So if we want, we can clean up this picture and look at it as that angle, side, angle triangle. So our angle, side, angle triangle, I'm just going to re-sketch the triangle with the pieces that we know now. We now know that this angle measurement here is 155 degrees. We know that this angle measurement here is 15 degrees, and we know that this side length down here is 1,800 feet. Now the good news is that what we really want is this side length C in terms of the angle measurements here. But to do that, we need to find this last angle B. Well, what's angle B going to be? Angle B is going to be 180 degrees minus 155 degrees minus 15 degrees, which I then get to be 10 degrees. So I know that this angle B here, here, and here is 10 degrees, just replicating it in both of my pictures if it needs to be cleaned up. Well, then I have the angle opposite that side length L. And so specifically, there's my law of sines that I needed. That's going to be 1,800 feet divided by sine of 10 degrees is equal to, now at this point we just need to figure out what we need. Well, we need to find side length C. So side length C divided by sine of angle C, but we know that angle C is 15 degrees. And so then we're almost finished. Multiply both sides by sine of 15 degrees. I then get that C is going to be equal to 1,800 times sine of 15 degrees divided by sine of 10 degrees. Now, notice that this one said do not round until the final answer. I should be typing into my calculator 1,800 sine 15 degrees divided by sine of 10 degrees. And when I do this, I get to round it to two decimal places, and I find that this is 2682.86, rounded two decimal places. Our unit is feet. What was our question? We just wanted the distance from A to B. We have found the distance from A to B, and we are finished. An aircraft at point Z in our picture is spotted by two observers, one at point X and one at point Y. We're going to pretend they're both on the same flat. Okay. Now specifically, we're told that they are a distance of 1,650 feet apart. As the airplane passes over the line joining them, each observer takes a sighting of the angles of elevation to the plane. So specifically, this person over at X measures a angle of elevation of 35 degrees, and this person over at point Y has a measurement of 50 degrees. Now, at this point, we're going to have to use some problem solving, because there's not a specifically direct way to immediately get side length h. Alright, I don't have a method to find that. Now, had I known the distance between point X and point D, or point Y and point D, I would be able to do it directly, but I'm not that lucky. Now, they've already drawn this as a couple ways, and so I want you to see what I see. So I see 3 triangles, one big one, and 2 little ones. Here, and here. Now, how in the world does that help me? Well, let's just lay out a road map real quick. So we know that this section is law of sines, so might as well use the idea that I'm going to use law of sines. Well, if I'm using law of sines requires that I have some angles and some sides. I have specifically an angle side angle set up here, and so we can get this angle measurement for free, where this angle measurement right here is 180 minus 35 degrees minus 50 degrees. Okay, how does that help us? At that point, what I can then do is I can use the law of sines to find one of the unknown side lengths. I claim that once we find one of those side lengths, we can then essentially solve a single right triangle. Okay, it doesn't matter which one. Pick your favorite. That's the one we'll work with. So let's actually see this in play. Okay, so step 1, I need to find one of these side lengths. I'm just going to pick this one here. Does it matter? Absolutely not. I'm just choosing one to solve. So in terms of our law of sines, this would be side length A. Okay. So if I want to find side length A, we get this angle measurement. What do we say that was going to be? That's going to be 180 degrees minus 35 degrees minus 50 degrees. So I get that this angle Z is 95 degrees. Wonderful. Then I can use the law of sines here, specifically to get side length A. So what's that going to look like? That's going to be side length A divided by sine of 35 degrees. That is equal to angle sine of angle Z, which is 95 degrees, under the side opposite angle Z, which is 1,650 feet. Okay, solve for A, multiply both sides by sine of 35 degrees, multiply by sine of 35 degrees. And so then I get that A is specifically 1,650 times sine of 35 degrees, all divided by sine of 95 degrees. Alright, now if we were just trying to get approximate values for all the missing pieces in this problem, I claim we could do this exactly as is. But recognize that there's a problem. It says do not round until the final answer. Now, if you round far enough out, the error that you create by rounding should take care of itself. But I want to be extremely careful, and so what I'm going to do is I'm just going to go, well, the side length for A is really 1,650 times sine of 35 degrees, all divided by sine of 95 degrees. I know that's a little bit tedious, but it's okay, we can handle it. So that's our side length A. Alright, great. Well, at that point, if I'm trying to find side length H, what can we do? Well, specifically, I'm going to think about ratio of sides, because now I'm just going to look at a specific triangle. And so the specific triangle I'm going to look at is now this one. Alright, so if I look at that specific triangle, what do I know? I know angle B. Well, if I know angle B, I can find this angle right here, right? This angle here is complementary to B. Complementary to B, meaning that this is 90 degrees minus 50 degrees, because, of course, we have a right triangle here, right? This forces a right angle over here as well. Then this is a 40-degree angle, okay? We didn't even need all that, but I'm just calling attention to it. But what I do know is that if I'm given this angle here, this angle 50 degrees, and I have, or I'm looking for the opposite side of 50 degrees, and I have what is the hypotenuse, then I can say, oh, I know that that's then going to be sine of 50 degrees is equal to the opposite side over the hypotenuse, where the opposite side is not known. It's that h that's written there. That's the thing I'm trying to find. Divided by this thing that I found here, which is 1,650 sine of 35 degrees over sine of 95 degrees. Like I said, it's a little tedious, but there's really nothing wrong here. That's just a number. So then if I want to solve for h, what can I do? I can multiply both sides by that denominator. So I'm going to multiply by 1,650 sine of 35 degrees, all divided by sine of 95 degrees. I'm going to multiply by that on both sides. So over here, 1,650 sine of 35 degrees over sine of 95 degrees. And so now I'm just going to write this as one big thing. H must be 1,650 degrees, 1,650 times sine of 35 degrees, times sine of 50 degrees, I'm just playing fraction multiplication, all divided by sine of 95 degrees. And so then I just want to throw an extra set of parentheses there to be a little bit careful, but that should fix it. And then I'm going to round to 2 decimal places. And so then I get that my side length h rounded to 2 decimal places is 727.75. And our units were feet, so it remains in feet. And so there we are, not rounded until the final answer.